All right, this is part 3 of lesson 9.4, solving quadratics through factoring. Think carefully as you're moving through this lesson. I just told you in the previous video that setting this thing equal to 0 is really helpful when we're trying to use the zero product property, but always moving everything to 0 doesn't necessarily make sense. Here is an example of one I'd really like you to think about, and the reason why is I'm looking over here on the right side of my equation and I have 81, and 81 is a perfect square, and as I survey my entire quadratic, I start to observe that there are lots of perfect squares going on here, and the question I want to ask myself is, gosh, is this left side of my equation a perfect square trinomial? If it is a perfect square trinomial, I might not want to move this over and set it equal to 0. Set it equal to 0 might not be the best choice for us in this situation because there might be a faster way for us to proceed. We might be able to use the square root property of equality in a different way. So let's think about this. Is this a perfect square trinomial? Well, 4 is a perfect square, and the square root of that is going to give us 2x. And the square root of 25 is 5. All right, so if we multiply those together, we get 10x. And if we double it, oh, yes, indeed, this is a perfect square trinomial. So in factored form, this perfect square trinomial ends up being 2x, square root of the first term, and then we keep this plus sign right here, 2x plus 5 squared equals 81. So notice I did not choose to move the 81 over in this particular example. So now we're all set to use the square root property of equality to unlock the left side of this equation. Remember, this just releases the radicand, so now I have 2x plus 5 is equal to plus or minus 9. Okay, so I'm going to subtract 5 from both sides, remembering that now I have 2x over here, and on this side I have 9 minus 5, and we also have negative 9 minus 5. So I have 2x equals 4, and I have 2x equals negative 14. So dividing by 2 on this side gives me x equals 2. And on this side, if I divide by 2, I have x equals negative 7. My final answer is x equals negative 7 and 2. So when you're solving through factoring, you don't always want to set this thing equal to 0, especially if there's a perfect square trinomial involved. But let's look at another example. Sometimes you're going to have to factor quadratics that don't have a leading coefficient of 1. So here's one last example for you to think about. I have 3x squared minus 12 equals 9x. Okay, 3x squared minus 12 equals 9x. If we're thinking that we might want to use the zero product property for this one, then we'd go ahead and put this thing in descending order. 3x squared minus 9x minus 12 equals 0. So we've put that in standard form, and now we're going to look at the factors of negative 36 with the sum of negative 9, and you guessed it, that would be negative 12 and positive 3. So we can blow up our middle term, and we can have 3x squared minus 12x plus 3x minus 12 equals 0. That means that we can factor by grouping. We get 3x minus 4, and if we pull out the 3 on this side, we get x minus 4, and this whole thing is equal to 0. So we have 3x plus 3 times x minus 4 equals 0, and then using the zero product property, we have 3x plus 3 equals 0, and we have x minus 4 equals 0. This allows us to figure out that x is equal to 4. Or if we subtract the 3 on both sides, we have 3x equals negative 3. We figure out that x is equal to negative 1. X is equal to negative 1 or 4.